So this video is going to be about how to go from angle magnitude form, or magnitude angle, depending, into component form. And the next video is going to be the other way around, going from components back into magnitude angle form. And if you've read the packet, there's really it's straightforward. Because of the fact, in fact, this one is in the fourth quadrant, right? So we'll just sketch it real quick. 28 at about 34 degrees, so we'll just say that's 28. So here's our reference angle, the 34 degrees. There we go. And the length of it is 28 units. Now, its x component is this, and its y component is this. Notice we have the right triangle. And we've mentioned this earlier. For the 34 degrees, for our reference angle, the y is opposite, and the x is the adjacent. And this, of course, is the hypotenuse, which leads us to, we'll call this vector A. I think that's what they use in your packet. So if your vector is A, then its x component is going to be the vector A, the magnitude of that vector, that's what these lines mean, the magnitude, in other words, the 28, times the cosine of the angle involved, the reference angle. Actually, you don't have to use the reference angle. You could be using the other angle. I'll just put angle for now. So notice that the cosine, right, which is adjacent over hypotenuse, is, and this, by the way, would be your hypotenuse, right? And this is your adjacent, and that's what you're looking for. That cosine makes sense because that's what we're finding the adjacent side. So cosine is going to go with x. For the most part, you're going to want to have that as kind of an automatic response. Cosine goes with x. There will be, as I mentioned before, a couple situations where it will be, where that won't be the case, but we'll cross that bridge when we come to it. All right, what about the y component? Well, A's y component is going to be the magnitude of A, the 28 in this case, times the sine of the angle, in this case the 34 degrees. So let's figure out what they are. X component is going to be 28 times the cosine of 34 degrees, and the y component is going to be 28 times the sine of 34. I'll break out our calculator here, and let's see, 28 times 34 cosine equals, so that's 23.2, and then we'll do 28 times 34 sine, and that's going to be 15.7. Well, let's double check. Does that make sense? Sure, that makes sense. That should be a little smaller than this. Now, the only thing that's left is we need to know where we are. And this is easy to make a mistake on, but we want to be very careful here. One of these is negative, and one's positive in this case. Because we're in the fourth quadrant, we really have this. So if we want to write vector A is going to be, x is positive, so it's going to be 23.2 is the x component, negative 15.7 y component. The y component is negative in this case. I used the reference angle, so my computer didn't tell me that, but I'm supposed to know based on the information that I'm given. They would have presumably in this one given me, yep, there it is, fourth quadrant. All right, so what you want to do is find the packet, practice this. It's just applying these two short little equations, which are just trig relationships that we worked on earlier. All right, and use that to find the two components. Double check your positive and negatives, and I highly recommend making a picture to help so you don't mess up where the components are positive and negative.